Okay, so far so good. We got Jeremy, Dimitri, and Mr. Yang. And as more people come on, we'll be able to see them. Let me adjust my screen here. Cool. And adjust this down here and go to here. Nice. Come on now. Okay. Go up here. Done with this document. Cool. All right. Let's see. One person waiting. Carlos is waiting. Get my mouse back up in here and admit Carlos. So welcome, Carlos. So in this particular view, can you all see each other's names on the screen?
Yes.
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 Wonderful.
Yes.
Wonderful. Okay, so in a few minutes, hopefully everybody else will join. I started this early only because my afternoon class, I started it early also, but like closer to 4 minutes too. And for some reason, I wasn't able to click in through my laptop. For some reason, it clicked in through my cell phone. And then I find myself talking to my cell phone and then talking to the laptop. Something's wrong. There's two. I shouldn't be logging into two different places. So we just dismiss the cell phone and stay with the laptop. Cool. All right. We'll see as other people need to join in. That'll be fine. Taking a look up here. Close this guy. Close this guy. Close this guy, and then right in here. So of the fellows that I happen to have on the screen presently, of the people I have on the screen presently, I need to check and see which version of Windows you are using. So Carlos, what version of Windows are you using, sir?
Windows 10.
Windows 10, okay. And Jeremy, what version of Windows are you using?
Windows 10.
Windows 10. And Mr. Yang, Chan?
Windows 7.
Windows 7, okay. And then Dimitri?
Windows 10.
Windows 10, okay. All right, so let me direct my question to Mr. Yang. Chan, with Windows 7, were you able to complete, I didn't look at all the uploads yet today, were you able to complete the installation of all of the different parts per my and Nabil's instructions, yes or no?
I'm able to install all the program, and the last part, when I do the impact to the, actually on the circuit board, I have a problem with that. But installation of the program, have no problem.
Okay, now installing the program, there's several different parts. I'm not talking about Eagle, we'll leave Eagle aside, the Active-HDL. With Active-HDL, there's also Xilinx, and then in addition to Xilinx, there's the ISE pack, and then the pack has to be activated. So were you able to finish Nabil's instructions for activating the ISE pack?
Yes, I'm able to do that.
Okay, so the ISE pack software is what allows Xilinx to communicate with Active-HDL to complete the synthesis process. So were you able to complete the synthesis process on step 22?
Yes, I'm able to do that.
Okay, then the very last part was, the last part is the connection into the FPGA board itself in order to get the LEDs to work. were you able to make the connection to the FPGA board, your Digilent board, to
Yeah,
get the LEDs to work?
No, I'm not able to do that. That's the only part that I have a problem.
Okay, okay, all right, all right, all right. I'm just getting a poll of where things are. The good news is, yes, we have, oh, let me get Gerardo on here, admit Gerardo. Welcome, Gerardo. You should be able to see your classmates' names on the screens now. We were just taking a poll of who has what version of Windows. So Gerardo, what version of Windows do you have?
10.
10, okay, all right. And, okay, just taking a poll. We'll wait for other classmates to come on. Hopefully they will be with us in short order. So here's the thing. With Windows 7, Nabil is able to get everything to work with Windows 7, from the installation of the Active-HDL, the installation of the Xilinx, the installation and the activation of the Xilinx with the ESYS service pack, and be able to get past step 22, which is the synthesis, and beyond that was the final connection to the FPGA board in order to get the LEDs to work. So that works completely 100% with Windows 7. We have not, however, tested this with Windows 10 yet, only because our school computers are not updated to Windows 10, so we've never had to make that transition. So that's where we find ourselves. So what's going to happen is Nabil is going to work on a Windows 10 machine and see if there's some compatibility issues, or where we might have to go a slightly different step in a certain process. Let me get Mateos on. Hold on one second. Now Mateos is on with us as well. Boy, look at you. You look like somebody we're ready to hire. You look like you just went to a job interview. Or maybe that's just a static picture that he chose to put on. That's okay too.
So Professor, I was able to get through all the steps and make my side leg work fine. I was able to activate it and pretty much through all the steps and make sure the LED works using my Windows 10.
So you were able to get everything activated, the ISE service pack, and the last step of connecting to the Digilent board and make the LEDs work.
Correct.
Outstanding. So it does work with Windows 10. That was the big question as to whether or not that set of instructions was able to get people through Windows 10 in order to get to work with the board. So with that being said, Gerardo, the way that you would demonstrate your finish of the project is to do a short video with your cell phone and flip the switches of the LEDs, flip the switches, demonstrating that the LEDs are working the way that they're supposed to. And that video is probably maybe like 1.5 minutes. It's not very long, maybe 1 minute. It doesn't take very long. Hold the camera, have the thing on, and use a pencil or pen and narrate while you're doing this. Okay, this is what should happen when I flip switch 0. What should happen when I flip switch 1? What should happen when I flip switch 2? And as you flip the switches, you should be able to see the appropriate reaction of the LEDs on your particular board. And I can tell right away just by looking at it whether it's a Nexus 2 or a Nexus 4. So, and Gerardo, I believe you received the Nexus 4, right?
Yeah, I got the Nexus 4.
Nexus 4, okay, all right. It'll work. The software works with both boards, Nexus 2 and Nexus 4. I just want to see who was successful up to what extent. So that's excellent news. I will convey that to Nabil so he doesn't have to do extra cartwheels to see what's happening with respect to Windows 10. So confirm that it does work with Windows 10 as long as you follow the procedures. Where did you find, as we have communicated, you and I, in various steps through this past week, where did you find the biggest solution for the most recent impediment that you encountered? What was the most recent impediment that you encountered? Were you stuck on the synthesis for a little bit and then you were able to go around it by activating the ISE service pack?
Yeah, so I mean, to be honest, as long as the steps are, there were, I would say, a few steps that were cut off that you kind of had to figure out in order to get everything working. Specifically going into Alltech and going through to the tools and preference window, you kind of had to figure it out that you had to go through the actual Alltech window and not through the pop-up window that comes on when you first open.
Okay, so this is what I would ask you to do, and this would be for bonus points, if you could, Gerardo. If you could, not now, but sometime in tomorrow, make some time to list which step in our sequence of 21, 22, 23, 24, where you found that particular area of going to Windows tools and preferences that might be helpful to the rest of our classmates. If you could itemize that, you'll receive bonus points for that. I would appreciate that if you could generate that, because your information about it working successfully and you having success with this with Windows 10 is a huge thing, because it'll save Nabil hours and hours of having to redo everything on Windows 10, because it took him a long time to generate. It took both of us a long time to generate the information that we have for you all at this point. So now it's a matter of refining that information pretty much the same way we did with, remember ESYS 55A, where the previous documentation we've received, there were some bugs or some terminology that could be clearer, some steps that could be clearer, maybe some things were ambiguous that each person brought to my attention. And so we would update the wording and make everything more clear and relevant for the next time students are likely to look at this information. So whatever you can itemize in those areas that were initially challenges that you were able to overcome, that information in detail according to the step of our instructions, I will go ahead and add that into the instructions, and that'll be helpful to all of us. And when I say it could be something that, was it in Nabil's instruction set or was it in my instruction set? What area, what page, or what, give us some kind of reference number, and then we can go ahead and modify and update that for the benefit of all of our classmates.
Sounds good.
Thank you very much, Gerardo. That's really, really helpful to the team. All right, now let's see. I still have 1, 2, 3, 4, 5, and I've got a 6th person here. So Matthias, what version of Windows are you on, pal?
Windows 10, sir.
Windows 10. Okay, so 1, 2, 3, 4, 5, 6. That accounts for all of us who are on this call so far, and nobody else is pending. Bad on them. Okay, so that being said, I will keep an eye out on this screen as well as, because I got to see if somebody else is coming in late or not. But I do have some instructional stuff to discuss with you moving forward. So the biggest news, and I'll reiterate, and I'll probably do this again as more people come on, is that the March 31st expiration date has been extended to March 31st of 2021. Woo-hoo! So which is wonderful. But now the real work begins, because if you were stuck in some way, shape, or form at step 22, we'll look forward to Gerardo's added comments of how he was able to dig deeper and find in Alltech the tools and the correct preferences in order to get things working for the synthesis. And then after the synthesis is the connection of your software to the board, and upload the program to the board, and then have the board demonstrate that it is working as you've programmed it, based on the flip of the switches, demonstrating the correct sequence of LEDs that are lighting up. Okay, so that's what's coming up. So yes, we have our license extended, but now we have some additional work to do in order to make sure that we finish in 1, because unless you can get past synthesis and unless you can get your board to do things, there's no point going on to lab 2, because lab 2 requires lab 1 being completed. So that's where we're at. So we'll look forward to Gerardo's information, and as soon as I get it, I will share it with everybody. But your task between now and the next time we meet is to work diligently to review the instructional steps that I, Nabil, have generated and that Gerardo is adding for our benefit. So any questions as to what we need to do to complete lab 1?
Yes, sir.
Yes.
So, will there be like people who are moving on to lab 2? Or how many people besides Gerardo are able to finish lab 1?
So far, Gerardo.
Okay.
Yeah, but the biggest aha is this, that it does work on Windows 10. So the fact that Gerardo was able to make it work on Windows 10, as I said, saves Nabil an incredible amount of time having to redo everything he and I have done so far in Windows 10. So it's demonstrated that a student was able to do this. He does not have to spend countless hours regenerating the same information that he has already. So it's a matter of reading through very carefully what he's done. So yeah, to answer your question, only Gerardo has so far.
Oh, I got mine finished, and I posted as a submission. I sent a photo of the board actually working.
I'm going to need a little bit more than the board, Jeremy. Thank you very much for getting that to work. Thank you. So Jeremy, you also, if you would, as I explained to Gerardo, because certain flips of the switches result in certain LEDs lighting up a certain way, could you just use your cell phone and just do a narrated video recording of yourself? Here's what happens when I flip switch 0. Here's what happens when I flip switch 1, and then go through your narration until the appropriate switches have been flipped, and then the appropriate sequence of LEDs have lit up, and then just upload that into Canvas.
Okay.
Okay? So yay, 2 students. Has anybody else been able to, in addition to Gerardo or Jeremy? And that's with Windows 10. That's exciting. And I've got one with Windows 7. So that's fantastic. So Jeremy, let me ask you a question that may also be helpful as well. In the same spirit as we did for 55A, I'd like to append our documentation and make it even more friendly for everybody. Were there certain aha moments you experienced after the synthesis challenge? How did you get the ISE pack to be properly activated, or did you do anything special other than Nabil's instructions?
How I did so was,
yes.
Well, first, to even get the ISE downloaded, I did not download the Windows 10 version because it requires you to have an environment that can run a virtual machine, like Oracle. That's the error that kept saying was no VMS, no virtual machine environment detected. So on Windows 10, I downloaded the Windows 7 version and it worked with no issue.
Okay, all right, so send that back to me in I'm making notes.
Sorry,
Jeremy.
I have a question.
Who is asking the question?
Carlos.
Carlos, yes, go ahead, Carlos.
Yeah, so what I understand that Jeremy has a Windows 10 operating system. So what he did was he downloaded the Aldex software for Windows 7, and
Yep.
did it work on Windows 10?
Yep.
Oh, all right.
And the specific software that he downloaded was not the Active-HDL in Windows 7, right? The Active-HDL was in Windows 10?
No, it was the Xilinx ISE pack.
Okay, all right. But everything else, so that was the only one that was the Windows 7 version.
Yep.
Okay, and that worked out okay. All right, all right. And let's see.
And I did have a hiccup at step 22 at first, but then that was because when I downloaded the license for the Xilinx pack, I forgot to activate the actual file that it emailed me.
Right. That was the, yes.
And then once I activated the license through the file, then there was no issues afterwards.
Okay, all right. But it just turns out that you downloaded the ISE Windows 7 pack.
Yeah.
Okay, all right.
Because the Windows 10 required me to have specific settings in my BIOS. And I think Windows included a virtual machine environment, like running software.
Okay. Yeah, that was the moment that popped up was when I popped the question over to Nabil, and that's why he had said, well, wait a minute. The computer he was using at school to do all of the things that you all went through this past week was a Windows 7 machine. And he thought, well, maybe this virtualization issue was unique to Windows 10. So let me get back to Gerardo, if I may, for a moment. Gerardo, when you downloaded the ISE Xilinx pack, did you have any virtualization issues? Did any kind of error like that pop up? Did you use the Windows 10 version or the Windows 7 version? Do you recall?
Yeah, I used Windows 10, but I am running a VM software, so. Okay,
all right. Okay, so you have a slightly different solution. And for those people that don't have the VM or any kind of virtualization, the Windows 7 does work. Right, Jeremy?
Yes. Well, what I think it is that it has a virtual machine software built in with Xilinx, but you have to have it be able to run to download every other file. So when you don't want to download it, it'll cancel the download and won't let you download any files. So like I would always get stuck at maybe 60% download. I'd say no, and then it would say canceling download and all the files would delete itself instantly.
Okay, all right, that's very clear. Fantastic. So Jeremy, thank you very much for your input. Bonus points for that, for helping out the group. In addition to Jeremy and Gerardo, was there anyone else who was able to get the LEDs to work on the board? Get past the synthesis and get the LEDs to work on the board? Okay, then I take that as a no. All right. So we have a couple of solutions here. This is exciting. All right. So our marching orders moving forward. Yes, the software is extended for another 12 months, so we have use of it. Then we would recommend that you might try, if the issue you experience was in the Xilinx download, Windows 10 requiring virtualization versus Windows 7 not requiring virtualization. Even though you're using the Windows 10 machine, the Xilinx ISE pack can be downloaded in the Windows 7 version, and it will work per Jeremy's solution. Those of you who know that you already have virtualization in your systems and that works for you, then the regular ISE pack should work fine for you, but you have to activate the software per Nabil's instructions. Otherwise, just downloading it without the activation will not allow the synthesis to complete. And unless synthesis completes, then we have no ability to connect to the FPGA board. So that's what you get to work on for part of this next week. I have some other things that I'm going to be discussing with you, and that has to do with your reading assignment. Before we go on with that, are there any other questions that you may have?
Yes, one more question, sir.
Yeah, sure, by all means, Matthias.
So are you suggesting that we do what Jeremy did?
You're going to need to do whatever it takes to get it to work on your system. And if you are not sure whether your system has virtualization or not, when you go to download the ISC pack, when you downloaded the ISC pack, presumably you did you encounter any virtualization error messages?
For the ISC 14.7, I got a error message that said installation cannot be performed. Please fix the issue before installing. Virtualization is not enabled in BIOS.
There you go. So yeah, exactly. So you have the virtualization issue. So since you do, then I would recommend that you use the solution Jeremy was able to find, and that is go back to downloading the ISE pack, but instead of selecting Windows 10 version, select the Windows 7 version. So the answer to your question would be a yes.
Okay.
Okay?
Yeah.
Cool. Any other questions so far? Good questions. Okay, all right. Let's go ahead and talk about the lesson for this evening. I'll keep an eye out for other participants. Let's go take a look at, let's see who sent what message here so far. Oh, okay. So Gerardo, yeah, I just happened to see a separate message from you at 6:06 saying that the TINA software works. So I'm glad you got the TINA software to work. Yes?
Yeah, I just couldn't see the images you had uploaded, but you re-uploaded them and I can see them now.
Yeah, and thank you very much for bringing that to my attention, because sometimes we find Canvas, as wonderful as it is not a perfect system. And so as different things upload, if for some reason it looks clear on my side, some students can see it, some students can't see it. If for whatever reason any of you can't see something that I'm referencing, or that anything that your instructor in different courses are referencing, please let that instructor know immediately. And the simplest thing that we instructors can do is simply remove the existing item and reload the same item. And sometimes with the reloading, there's a better connection with Canvas, which allows it to be visible. So I just saw that note and I just wanted to comment on that. So I'm glad now you're able to see our task in a different class. But let me get back to our class. That's good. I was just checking to see if any of your classmates had made any indication why they are not part of our meeting tonight. So even though this session is recorded, Zoom, we have found out with Zoom's not a perfect system either. What we found out with Zoom is they may or may not be able to save all recordings from everybody who does a Zoom meeting. And if they are able to save a recording, we might not get it right away. So it really depends on the amount of use during the course of which day of the week. So yes, I have everyone, my intention is to record every one of our sessions so that if anybody happens to miss, bad on them, because they miss the interchange and they miss being able to respond to my questions, and they miss being able to ask questions that some members of the group would be able to give us a solution for. And so, such as, Mateos had a follow-up question. He wanted to clarify, should I use this route? Should I use this route? And based on comments shared by other classmates, Mateos being here was able to ask that question. So we have a few students that are unfortunately not in our session. Bad on them. So let's go to here. I'm on a different monitor, pardon my eyeballs. And 55B, cool, here we go. And we have some reading from the Kupholz book. And I know it's been a period of time since some of you have looked at the free textbooks that we have via Mr. Kupholz. And let me get to the right course here. One thing I have found, because Zoom works the way it does, it reduces the speed of how everything else I do. So bear with me. And come on. Is here and here. Cool. So the reading had to do with numbering systems, and we're going to review how the numbering systems are constructed, and then we'll start talking about logic. So, and or applications, that's right. And how many of you have read the comments that I have replied back regarding your and or examples? Because what we're looking for is electronic circuit examples. So, for example, if you get into your car, you're not able to start the ignition. The engine won't start unless the key's in the ignition and the seatbelt is buckled in some cars. If you buckle the seatbelt but you don't turn the ignition key, it won't go on. If you don't have the seatbelt buckled and you turn the ignition key, it don't go on. But in certain cars, the logic is set up as you must have the seatbelt buckled and you must have the ignition key turned on before the engine turns over. So that's an example of an AND function. So the seatbelt sensor and the ignition key are both locked into an AND gate, and that AND gate systems must be, both conditions must be true in order for the outcome to be true, and the outcome is turning over your engine. The simplest example that I gave you for the doorbell, a front and rear doorbell, that's the example of an OR system. And that again is another electronic system where if you ring the front doorbell, if you push the front doorbell button, then the doorbell inside the house, the chimes will ring. Or if I'm at the back door or the back gate and I press the button to ring, then that will also ring. So either or button push from the front or the back of the property will ring the bell, the doorbell chime set in the house. So that's an example of an OR condition. So the comments that I made were in reference to looking for your examples to reflect electronic conditions, some sort of electronic scenario. And so if you replied with some sort of electronic scenario if you replied with a scenario that was not electronic, I made that comment. And if you chose to redo it, which you can, then I'll be happy to, as soon as you let me know that you've redone it, then I'll be happy to review it and increase the grade. Any questions regarding that and or exercise? No? Okay, fine. Let's take a look at this. And, oh, okay. Mr. Sanchez, Edwin is on, so let me admit him. Hello, Edwin, say hi to everybody. Welcome to our session. You need to unmute your microphone in order for us to hear you, my friend. Okay, he's getting it set up. So Edwin, your microphone is on now?
Yes.
Okay, cool. And Edwin, what version of Windows 10 are you using? Hello, Edwin?
Okay, I can hear you now.
Good. Edwin, what version of Windows 10 are you using?
The OS.
Yeah, is it OS 7 or OS 10?
OS 10.
OS 10, cool. All right. And were you able to complete the exercise to get the LEDs on your circuit board working?
The LED jumbo?
No, no, that's a different class. This is 55B, and we're talking about the Digilent Nexus boards. Let's see if I happen to have one handy here. That's around somewhere.
Well, the answer would be no. Now,
Yes.
Yeah,
Okay. All right. So the answer is no. All right. So what you're going to need to do, my friend, to bring you up to date, the licenses have been extended for a full year to 2021. And the explanation on several solutions were discussed in the half hour since 6 o'clock. So you're going to need to review the video when this video becomes available. But
Okay.
we have had some...
From the previous class session that we had 2 weeks ago, we agreed that this was going to start at 7 o'clock. That's why I'm checking in right now. The 5th.
It's okay. All right. Yeah,
so
but
that's why I thought.
But I sent out emails. I sent out emails a couple days ago, and I sent out an email again today.
Yeah, I saw the link being sent. That's why I clicked in. But anyways, yeah, I'll review the video.
Yeah. Review the video. The videos from our friends at Zoom may take some time for them to actually make them available to me, because everybody in the world is using Zoom for all different kinds of meetings, business as well as education, as well as personal. So Zoom has just exploded. The usage of Zoom has just exploded. But we have two classmates that have been successful in getting this working all the way through the LEDs, and they are going to be shooting videos for me demonstrating the flips of the switches of the board, and demonstrating that certain LEDs will be lighting up at the appropriate time. Okay, so solutions are in effect and licenses have been extended, so we are good to go for the remainder of our time together with the use of these boards and the other things that we're engaged in. So that being said, welcome to our session. And I was looking for, okay, yeah, we just finished talking about the example of the and/or circuitry and the homework. Not everybody's response was based on an electronic example. So I was looking for electronic examples, and I gave a couple of electronic examples just before you linked on. So listen to those if your score was not at maximum. Yeah, your score was at maximum, so I think you were okay. Anyway, question.
Yeah, I did. I didn't have the right examples on the first time, but did you see my second examples that I
No, I haven't looked. No, I haven't looked at anything yet. So that's the purpose of us having this conversation. So those of you who have resubmitted or are going to resubmit in the next 24 hours, let me know now. So that would be gear that I'm going to be looking at. Yes. Anybody else that I'm going to be looking at?
Yeah, Dimitri, I resubmitted mine.
Okay. So relook at and or. And we look at and or. Anybody else did a resubmit?
Gerardo did.
Gerardo did a resubmit. Cool. All right. So relook and or. And Chen Yang, did you do a resubmit?
I haven't done it yet, but I'm going to.
Okay. So I will see it before noon tomorrow. Yes.
Yes.
Okay. It'll just come up with the. Okay. That's good. So relook and or. Cool. Okay, as long as I see them before noon tomorrow, then I'll go ahead and make the adjustment sometime tomorrow. I have a 12-to-1 meeting, and I'll be looking at grades after the 1 o'clock meeting. All right, so I have 4 people that I'm going to be reviewing, so it'll be Mateos, Gerardo, Dimitri, and Chan. Anybody else? I think everybody else gave me nice electronic examples. Cool, all right. Very, very good. Now, let's go ahead and take a look at, all right. This is the meat and potatoes of what I want to see. So I'm going to share a screen for you just for a moment. Do share, and I'm going to go here, and I'm going to go share. Okay, so now can everybody see my Canvas screen?
Yes.
Cool. So as you're looking at Canvas, what's interesting, if you have Canvas open also, can you confirm whether or not you see Studio that I'm pointing at right here? Can you see Studio on your Canvas screen?
Jerry does not see it.
Jerry is a yes or no?
It's enough for Gerardo.
Okay, so no for Gerardo, no Studio.
Carlos, no.
Carlos is a no. Carlos.
Adios. No.
Who else said no?
Germa.
Girma. Okay, no for Girma.
Chen Yan say no also.
Okay, so Chan Yang says no. Well, enough of you are saying no. It's really, that's fine. I'll just take it as none of you can for whatever reason. You can see it on my screen though, yeah?
Yeah.
Yes.
Yeah.
Okay, okay. Studio is one of many options. As you can see over here, these are options that you don't see because instructors have made them not active. So these that are available or should be the ones that you should see active. You can see Confer Zoom, yes?
Yeah.
Okay. So these are the new ones that, not new ones, these are the ones that most recently the school has asked us to activate on behalf of the students to give us more Zoom capability. Before, anybody who signs on to Zoom would be allowed a 40-minute session and a limited number of guests. If we're on the educational version of Zoom, we have an unlimited, well, I don't want to say unlimited, but I can go on for over 3 hours and I can have up to 400 guests. So that's what Confer Zoom will allow. But they've also asked us to activate Studio. Studio has always been in this bin down here of other things we've not used before. And what Studio is used for is for us to pack any videos. So our session, for example, will be put in Studio. I won't put it in Studio because you guys can't see it. So what it is that you'll see under week 2 is I will go ahead do this. I will go ahead do this, and this will be WK-2 Zoom class session. And hit add item. And bring us up here underneath reading assignment. I will come over here and open this guy up and edit. See, it's not published yet. Not published. So I will go ahead and add a point value to this that there will be, actually your attendance is going to be more than this. So I'll say 25 for this one, but your attendance will be 100 points for being with us tonight. And so this will be due, and let's say here, save and publish. And all that I'm going to need for you is under submission, hit yes, online submission, text entry, media recordings file, whatever it takes. And that's fine. Any format of letting me know, yes, you've had a moment to review our Zoom session. So that's a 25 pointer, but tonight's attendance will be 100 points. So having the Zoom recording in this particular format to be able to view will be helpful for those that aren't here, but nowhere near as helpful as actually being here. What you're going to actually see in here at the appropriate time will be something like this. Let me go here and show you, because I don't have anything to upload for you and I to view at this moment, but I do have in a different course. Those of you who are with me in this other course, you know what I'm talking about. So Zoom. I put it in here. Yes. So a video that we will port into Canvas page will appear as a blue box with a white triangle. Is everybody able to see this?
Yes.
Okay.
Yeah.
So our Zoom meeting, all you would have to do is just hit this little white triangle and then it'll launch and then you'll be able to see and hear the contents.
Well, hello, my friends.
Okay, anyway, that was something that I recorded for our 51 class. That was a short 18-minute video, so that runs pretty well. So you'll have the same thing here, a day or no more than two, hopefully no more than 2 days, you'll be able to see something loaded in here for what we've discussed for today. Any questions regarding Zoom that you can review for our class? Okay, now let's talk about the lesson for this evening. That's right here. And reading assignment. And in reading assignment, I put down from the Cup-Holtz textbook, read digital logic gates, blah, 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 blah. And I believe, if I'm not mistaken, where's that up here? Course textbook, syllabus and course textbook. Yeah, under syllabus and course textbook near the top, you have a PDF version of our digital textbook, Cup-Holtz. So you need to let me know that yes, you can click it. Yes, the textbook is available to you, and that you can confirm the download of the PDF. And you can also confirm opening the PDF, be able to see this page. Could all of you do that now, please?
What's the page? Is it under week 1 or week 2 or syllabus?
Under syllabus. It's under syllabus and textbook. It's right. Syllabus and course textbook. Click that guy open. And then you'll see it right here.
Germa, the PDF is working. The
Cool. Okay, so has book. Cool. Jeremy, are you able to get it?
Yes.
Has book. Cool. Carlos?
Yes.
Has book. Edwin?
Yes.
Has book. Gerardo?
Yes.
Has book. Dimitri?
Yes.
Has book. Cool. And Chan?
Yes.
Has book. Okay. Cool. All right. So everybody has the book. Everybody can. My recommendation is, since it's when you click it, it goes into your download file. Go ahead and save the book on your computer, thumb drive, wherever it's convenient for you. That way, anytime you want to refer to the book, you will not have to keep going into Canvas to look at it. It'll be immediately available to wherever you have your access to it. So there we go. In the textbook, we happen to have 517 pages, if you hadn't noticed. We won't be going through all of those pages, but we will be going through some of them. And if you take a look at the first 2 chapters that we're responsible for reading, and going into next week, we'll be looking at chapter 3. So chapter 1 is numbering systems, chapter 2 is binary arithmetic, and then chapter 3, logic gates. So let me go ahead and begin our lecture on the numbering systems, and then we will go and talk, and I'll introduce you to our logic gates as well. So I'm going to switch from stop share. Were there any questions regarding your textbook before I get into the lecture tonight?
Well, I did have just one question, Mr. Ko.
Yes, sir.
So, you made that 25-point Zoom conference page.
Yes.
And do we have to do a submission for that, or are we just going to be?
Yeah, you're going to comment that you've looked it over, that you've received it, that it works, and that you've looked it over, and you get 25 points for that. But the biggest points is being on our class tonight. It's 100 points for class participation.
Okay.
The answer is yes, there is a submission. Your simple text comment that yes, I have reviewed, I've demonstrated that the video does work, and I can review it at my leisure.
Okay.
Okay, cool.
Yeah.
Nice. Okay, any questions regarding the textbook? Okay, let me switch my video sources now to my .cam. Here's my .cam. Move this over this way, and this guy over to here. All right, so right now it's a blank piece of paper. Let me do this. So I'm going to talk about, see how well this pen works for me. All right. Okay, let me change the view. Speaker view. Okay, so in speaker view, I'll move this over. Yeah, stop and focus for me. I have to move this to a different screen. All right, now I can see more clearly. All right, so can you see my writing clearly stating numbering systems? Yes?
Yes.
Yeah.
All right, so here's what you need to know about numbering systems. And base 10. So base 10 is an expression that we use, meaning that it is actually based on tens. And the way we have constructed the base 10 numbering system, most people really haven't thought of the structure of our numbering system. We've just used it. If you can spend money in a grocery store and you can get change, if you can get, press the button, focus, okay. Yeah, if you can get change and count change properly, then mama and papa have taught you well, such that yes, you can survive in the world without being cheated. So, but what does all that mean to us? So I put down here, that's not a good example. I'm going to change this, make this a 6, and make this a 7. Okay. So 170, comma 860. Does that have some significance to each of you?
Yes.
Do you have a sense as to that there's a sense of meaning to this, okay? And what gives it meaning is that I have a dollar symbol and I have a comma and I have a decimal here, and you say, oh, wow, wouldn't I like to, how many of us would love to have that as our annual salary for the year 2020? Let's sign up for that right now. But what we don't think about is how this numbering system is constructed, and that how all numbering systems are constructed similarly to this. We say that base 10 is based on tens. So here's what we're going to do. This will be 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. So what I've written is a bunch of tens, each one with a different power. This has the exponent or power of 0. This has the exponent of 1, exponent of 2, 3, 4, 5, 6. And all numbering systems are constructed with the same structure, except we have a different base. So if we're dealing with decimal, we're dealing with the base 10. If we're dealing with binary, that base would not be a 10, that would be a base of 2. If we're dealing with octal, that would be a base of 8. If we're dealing with hexadecimal, the base would be 16. But they're all constructed the same way. So there's a couple things that I want to add to the side here, and that is any base to the power of 0 equals a value we call 1. Any base to the power of 1 equals itself. So make sure you make a mental note of that, because what I'm going to do is I'm going to construct columns here. And the columns that I'm constructing, these are called place value columns. Okay, place value columns. Each one of these columns holds a very specific value in its place. So what type of value is this column going to hold? Well, what do you see? You see a base of 10, and what's my exponent? 0. So do I have a base to the exponent or power of 0? So what does that first column represent?
1.
Represents ones, okay? So I happen to have ones in here. Ones. And then if I move the next column over, I have a base of 10. And what is my power? The power is 1. What is base to the power of 1? Base to the power, any base to the power of 1 is what? Itself. And the base is 10, therefore this column represents tens. What is the base of 10 squared?
100.
100. Exactly. So this column represents 100s. This represents 1 kilos. This represents 10 Ks. This represents 100 Ks. 100 Ks. And this represents 1 megs, 1 millions, yes? Okay, is that right?
Yes.
Okay. So if you were to see this, these digits popped in here, I happen to have I'll pop them in here, 1 and a 7 and a 0 and an 8, 6 and a 0. So this is something we understood already without having to go through this construction. You already understood. How many single dollars do we have? None. How many tens do we have? 6 of them. How many $100 Benjamins do we have? 8 of those. How many 10,000s do we have? How many thousands do we have? 0. How many 10,000s do we have? There's 7 of those. 70,000, right? And how many 100,000s do we have? There's only 1 of those. So that's how we've grown up learning the decimal numbering system, is by counting numbers and by counting primarily currency. And most recently, those of you who are in any of the STEM classes, engineering, electronics, mathematics, any of those, then you'll be engaged with scientific notation and exponential notation and metric notation. That we understand very well. Now, something new on the horizon would be base 2. Base 2 is based on 2's. This is what we call binary. And here, the structure of putting together our place value columns is identical to this structure, except we just have a different base. So for example, I'm going to put down here 2 to the 0, 2 to the 1, 2 squared, 2 to the 3rd power, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. That's about as far as I'm going to go here. And we will go ahead and construct our columns. And if I take a look at the very first one, I have 2 to the 0 power. What is my base in this expression? The base in this expression is a 2, yes? What is my exponent here?
0.
0. So what did I write down here? Any base to the power of 0 is going to be equal to what?
1.
Ones. So this column represents ones. Just like that column represents ones. What do I have in the next column? Next column, I have a base of 2 with a power of 1. Do I have a base to the power of 1? What is that equal to?
2.
Itself. In this case, itself happens to be 2. So this represents 2's. Then this one, you double the 2. 2 doubled would be 2 squared, which would be 4's, right? And you double that, you get what? 8's, and then you get 16's, and you get 32's, and you get 64's, and you get 128's. And if we extended further, we would be able to get 256. It just goes on. So your binary structure is based on the same structure of this numbering system, only we're playing with a different base. How are we, if I were to give you a value in binary, so let me give you a value in binary. Suppose I give you a value in binary that looks like this. 1, 1, 1, 0, 1, 0, 1, 0, 1. And I'll put a little b here to designate that this is binary. Your job is to interpret what this binary is to convert. So task is convert to decimal. So your task to convert this binary sequence into decimal. And the way that you do this using longhand math, it's very simple. You start on the far left-hand side. As you start on the far left-hand side, you go to see what is, because we're going to pay very close attention to place value columns. What is the place value in this far left-hand column? The place value is what? 1/28. So in this particular process, what you're going to do is this will give us 128, and we're going to add this to the next, or I'm going to add it to this way. Add it to the next column. Next column, what do I have? 64 is the place value of that column. Do I have any? I have 164. So I'm going to put 64 in here, and I'm going to add it to the next column. Next column represents 32's, but do I have any 32's? I do not. So this will be add a 0. And then I'm going to keep adding, going to the right. Next column represents 16's. Do I have any? I have a 1 16 in here. So that means I'm going to add 16. And do I have any 8's? Add a 0. Do I have any 4's? Add a 4. Do I have any 2's? None. Do I have any 1's? 1. So your conversion is after you interpret each one of these binary values in their specific place value columns, is to do the computation of, I've got 128, one of those, I'm going to add that to a 64, so that looks like that's going to give me 192, 192, so 192 add with this will be 208, 208 add with this will give me 212, 212 plus this will give me 213, yes?
Yes.
Would somebody check my math and see if that's correct? I think that's correct. All right. So that being said, I'm going to give you one for you all to do. Suppose you see the following sequence. Here's the following sequence. Suppose you see 1, 0, 1, 1, 1, 0, 1, 1 in binary, and you are tasked with converting this to decimal on paper. No calculator, Mama's math is what you're going to use. Let me help by bringing these column lines down. That'll help make things a little easier to see. So you think about that. I'll add things on the side, and then we'll check for answers in a moment. Okay, I've got a number. All right, so that being said, I'm going to be calling out for digits. Jeremy, what is the first digit of your converted value?
First digit would be 128.
No, I'm not asking you to do the math. I'm looking for the answer in decimal. What is the first digit of your answer?
Yeah, I didn't even finish it yet.
Oh, you didn't finish? It's okay. It's okay. I was just looking to see who may have finished, who can give me the first digit. Matthias, did you finish this process? Matthias, did you finish this? And do you have the first digit of the decimal answer? I'm looking for a yes or no. You may have stepped away.
Sorry, I thought I was on, I forgot I was on mute. No, I haven't yet.
Okay, hang tight. Carlos, unmute your microphone. And have you finished the calculation, and do you have the first digit of the decimal answer?
Yes, 183.
Carlos, you're not following directions. What did I ask Carlos for? The first digit of the decimal answer is a 1.
Oh, it's a 1, sorry.
I was going to have somebody else give me the second digit, somebody else give me the third digit, but no, Carlos had to just jump out and say, yeah, the answer is 170. He's so enthusiastic. All right. So are we in agreement that this works out to be 187 in decimal?
Yes.
Yes.
Okay. Is anybody having any issues with the conversion process?
Nope.
Nope. Okay, seems pretty straightforward so far. All right. So far, base 10 and base 2 are fairly easy. All right, the next one that I'm going to discuss with you all is something called octal. Octal. Like an octopus. Guess what? This is based on 8s, because that's how many tentacles there are on an octopus, yes? So based on 8, we're going to construct our place value columns the same way. You're going to start off with an 8 to the 0. You're going to then continue 8 to the 1, then 8 to the 2, then 8 to the 3, then 8 to the 4, maybe 8 to the 5. Let's see what happens. Okay. Then we're going to find out what each of those columns are worth. So in the very first column, do I have a base to the power of 0? And any base to the power of 0 is always going to be what? 1s. So this represents 1s. The second column, I have a base to the power of 1. So like I wrote up here, any base to the power of 1 is?
Self.
And since this is an 8, then this represents a column of 8s. Then this represents 8 squared, which is 64. And then times 8 again.
256.
256. And then 8 to the 4th power.
1024.
And then we have 1024. And then
9,000 something.
yeah, 9,000 something, yeah. Okay. Actually, it's insanely large. 8 to the 5th power. This can't be 10. I think it's bigger than this. Yeah, this is not 1024, my friends. It's 4096. Thought it had to be bigger. Okay. Yeah, this is 4096. And this one is 512. So this one is 32,768. We're dealing with some pretty obnoxiously large place values in just a very few columns, yeah?
Yeah.
Yeah, it's scary large, scary fast. So 8 squared is 64, 8 times 8 times 8. If I take the 64 and multiply by 8, if I multiply by 10, I get 640. So it would be less than 640 by quantity of 2 times 64. So 500 is more appropriate than the 256. And then if I have the 512 and I multiply that 8 times more, I won't have 1,000 and change. It'll be 4,096. Multiply this 8 times, I'll get 32,768. So immediately, if we go to compare, where is 10? 10 at the base with the exponent of 5 is 100K. 8 with the exponent of 5 puts us at 32,000. 2 at the base of 5 puts us at 32. So each one of these at the exponent of 5 gives us a demonstrably different place value column, yes? So here we go. I'm going to give you, oh, there's another thing that I needed to bring up. I'm so sorry. It had to do with numerals. If we go back to base 10, how many numerals are there in base 10? So I'm going to write down here, base 10 numerals.
0 through 9.
Symbols, yes. They are 0 through 9. So I have a total of 10 symbols there, yes? 1 through 9 is already 9. So the 0 gives me 10. There is no single symbol that represents 10 in the decimal system. In order for me to represent the value of 10, what do I have to do? I have to put a 1 in this column and then a 0 here. Yes, I have to use 2 digits, yes, in order to represent the value of 10. If I look at my binary numerals, you already know this, the binary numerals are simply 0 and 1. So how many symbols do I have? 2 symbols for the base of 2, 10 symbols for the base of 10. What are my octal symbols? My octal numerals
8. 0 through 7.
Are 0 through 7. That's correct. I'm sorry I bumped into the camera. So my octal numeral is 0 through 7. So that being said, if I were to write down the following quantity for you to decipher, let's go ahead and do this. Suppose I have a 2, 5, 7, 2, 9 in octal. And my task was to convert that octal quantity, because it's stated as octal, into decimal. Question mark. What would that be? So we would start, as we have with these other numbering systems, on the largest, place value column. And the largest place value column is going to be this column right here. The column place value happens to be 4,096. Do I have any 4,096s in there? I happen to have 2 of them indicated in there, yes? So 4,096 times 2. This will generate the following value. This will generate 8,192, yes? All right, I'm going to call out names for generating the rest of these. So I am looking for, me, can you give us what 5 in this column of 512 represents?
2,560.
2,560 would be correct. That's what would be represented by this column. The next column would be generated by Carlos. Carlos, we happen to have 7 64s in here. So what does that column represent in decimal? Seven times 64.
Sorry, I'm 71064.
Yeah, 7 times 64. So I'm looking for what that value represents in decimal.
I'm sorry, I can't barely see your numbers on my screen. It's a little bit blurry. It's my my computer's problem. I'm sorry.
Okay, well, with a calculator, multiply 7 times 64 separately.
448.
448 is what we would have here. 448. And then this next one, we have how many 8s? There's 2 8s, so that gives us, add a 16 in here. How many 1s do we have? We're going to add 9. So in decimal, we're going to add these quantities together. So this plus this plus this plus 25. Okay, now, without shouting out the entire answer in decimal, so enthusiastically as our classmate did, I'm looking for a tally of these guys. So the very first digit of my tally, question goes to Edwin. What's my first digit of this sum?
First digit would be a 1.
1 would be good. Hold there. And I'm now looking for a second digit. Gerardo, do you have the second digit?
No.
Now we're just summing these numbers here. 8,192, 2,560, 448, 16 plus 9. Chan Yang, do you have the next digit?
One.
Okay, the next digit is a 1. Very good. Followed by a comma. And now I'm looking for the next digit in sequence. Jeremy, do you have the next digit?
2.
2 is correct. Excellent. And now I'm looking for the next digit. Girma, do you have the next digit?
2.
2 is correct. And Carlos, back to you. Do you have our final digit?
Sorry, I don't.
Okay. Edwin, do you have our final digit?
That would be a 5.
That would be a 5. Done. And put a D here to designate decimal. Okay. So that is your octal numbering system. So if I were to give you a worksheet and I had some numbers on here, could you work out the math in a similar fashion to be able to make those conversions? Okay. Okay. Now, we have one more numbering system to cover, and the next numbering system is called hexadecimal. So let's go ahead and do this. Hexadecimal is based on 16s, and my numerals, I have to have 16 numerals, 16 individual symbols, not pairs of symbols. I have to have individual symbols. So the individual symbols for hexadecimal would be 0 through 9, because that's already 10. So what symbol do I use for the value of 10? Would be A
Through F.
B, C, D, E, and F. You are correct. The A represents 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay, so let's go ahead and put together a hex place value column chart. And this will be 16 to the 0, 16 to the 1, 16 to the 2, and 16 to the 3. And now let's see what each one of these dispersed to become. A base to the power of 0 represents what?
1.
A base to the power of 1 represents what?
Itself.
Itself, which in this case would be?
16.
16s, correct. And 16 squared would be our 256. And 16 to the 3rd power, there would be your 4096. Everybody okay with the place value columns?
Yes.
For exercises, we won't, I typically won't quiz or test students past the 4th column. So, understanding that we have these numerals, we're going to give you an example for you to decipher. And to decipher, we're going to have you do this particular sequence. So let's have you decipher C, A, D, F. And this is all in hex. So that's our task. So how we go about playing with this particular guy is we look at the first column. The first column has what value? 4,096s. And as we have 4,096s, how many 4,096s do I have? C. C represents what quantity?
12.
12. So 4,096 times 12. Big number. This generates 49,152. Correct?
Yeah.
Okay. Yes. The next column has what place value? 256s. How many 256s do I have? I have an A value. A is 10. So here you don't need a calculator. You just do what?
You just add a 0.
Add a 0, precisely. The next column represents 16. 16. How many 16s do we have? D, which is 13 of them. So 13 times 16 gives you 208. Is that right?
Yes.
The last column represents ones. And how many ones do I have?
15.
F, which is 15. So I have to add the quantity of 15. So this in decimal, my friends, will tally to a value. And I'm going to ask you all for first digits again. Okay, so Chan Yang, what is the first digit of my answer?
5.
5 would be correct. Very good. Now the next digit, Dimitri, what is the next digit of my answer?
Oh, I'm way behind, so not even there yet.
Okay. When the video recording of this becomes available, you do want to practice this through so that you feel comfortable with making these conversions. Okay. Gerardo, do you happen to have the next digit after the 5? I can't hear Gerardo.
My thing was muted.
Yes.
Is
A 1?
It's a 1, very good. And then followed by a comma. And then the next digit, Edwin, do you have the digit after the comma?
Yeah, that's a 9.
9 would be correct. And Carlos, do you have the digit of the 9?
Yes, it's a 3.
It's a 3, very good. And Matthias, do you happen to have the last digit?
5.
It's a 5. Okay, so that interprets to be a that. Is everybody okay with the conversion process?
One question.
Yes.
What do you write subscripts? What are you writing there? What's that subscript?
This is a D for decimal. That's a D for decimal.
And then, so hexadecimal, what do you...
I had an H here. After CADF, there's a little H right here.
That stands for hex. Okay.
Yes, sir. Yes. And then through this binary sequence, I wrote a little b. And in this binary sequence here, I wrote a little b.
Then it'd also be okay to do like 2, 8, and 16, and 10, right? For the different numbering systems, you do subscripts of...
Here, I'll tell you what, whatever you choose to use as a subscript, whatever is easy for you, put it in a box so we don't identify it as a value. Because you put a 2 there, some people might write a 2 after this 5 and all of a sudden think, oh, what's that 2 doing there? So it's easier if you, whatever you choose, if you think having 2s, 8s, 16s or 10s are better for you, just put it in a square like so, and that we won't confuse your numbers with any number associated with the answer. Would that be a reasonable solution for everybody?
It would be for me.
Okay, cool. And I think that makes it very clear what it is that we have. I got one more box to generate right here. That box right there for that quantity being a hex quantity. And in this quantity, I wrote O or OCT, whatever works for you, just so that we know that it is not a decimal quantity. Okay? Okay, all right. This is all that I have time for numbering systems, but I do want to do something else with you very quickly for just a couple of minutes. And that has to do with our logic function. And our logic function, I'll at least go through a couple of these because the book will jump into many more. So the description is called logic gates, and we happen to have a symbol that we use here. This guy looks like it's shaped like a bullet, and it comes out, and this would be an output.
It'd be an AND output.
This would be an AND gate. Yeah, so we would have inputs on this side. Inputs. And so we'll have an A input, let's have a B input, let's have a Y as an output. And this happens to be an AND gate. And the electronics for an AND gate would be something like this. I could have power plus V coming down, and then I would have a switch. Would have another switch, and then this would be, let's say, an LED. And then ground. So that would be an example of the electronic example of that, what I'm proposing the AND gate to be. So this would be your A switch, this would be your B switch. And let's see what's needed. So I'm going to do something here called a truth table. Truth table. And the truth table is set up very simply with an A input, a B input, and a Y output. And since we only have 2 gates, two inputs, the sequence is going to be rather short. So we'll have a total of 4 possibilities, 4 different combinations. So you have this symbol that's shaped like a bullet. This side has A and B. These lines represent inputs. This line over here represents what we call an output. I've labeled that output as Y. This is described as the AND gate, and the electronic symbol for AND gate shows a positive voltage source, a switch that can be opened or closed, a second switch that can be opened or closed, and an LED that'll light up or not. And the truth table will be explained with ones and zeros. So the initial condition is if I have a 0 and I have a 0, 0 would designate that the switch is not closed. I don't have a true. 0 represents 0 equals not closed. 0 represents a false. 0 represents false or not true.
Or low.
Not true over here. And it also represents a low. Now in electronics, the low would be somewhere around 0 to about 1.2 volts. Somewhere in that area would be representing a low. So that's what a 0 represents. And a 1 represents closed. A 1 represents a condition we call true. And a 1 represents a condition we call high, which would be from somewhere around 4.2 up to 5 volts. Ideally, it would be 5 volts, and ideally this would be 0. But in the real world, we can have it go a little less than 5, and it'll still give us a true. Okay, so I have a 0 and a 0. So if both of these are open, do I have any possibility for electricity to go through?
No.
None. The LED will not light. So if the LED will not light, I will have a 0 here on the output. Suppose I leave A open, but I close B. So A is open, but now I close B. Will any current go through?
No.
No, because A is open. My LED is going to be off. So I have a 0. Suppose I close A, but I don't close B. So this one's left open, but this one's closed. Do I still have any current going through? No. So is my LED going to light up, yes or no? The answer is no. So my truth table says I'm going to have a 0. Suppose now I'm going to close a 1 and a 1. So now I close both. If both of these switches are closed, will I have electricity going through?
Yes.
Yes. And will the LED light up?
Yes.
Yes.
Yes. So therefore I will have a 1. Now this is a very basic 2-input truth table, very basic 2-input AND gate. If I happen to have 3 inputs or 4 inputs or 5 inputs, my truth table would be much, much larger with many more combinations. But do you see the binary sequence that is being constructed here? The binary sequence in the first row is a 0. The binary in the second row for here, for A and B, is a 1. The binary over here is a 2. And the binary for a 1 and a 1 is a 3. You follow what that part looks like? If
Yes.
we relate it to our previous place value columns, this represents 1s and this represents 2. So I have 1, 1, 1, 2. I have a 2 and a 1, which gives me 3. So the sequencing is always set up in an ascending binary order. The next thing is going to be this guy. It's kind of shaped like a shield, like so. Y, and here, this is my A, this is my B. This particular guy is called an OR gate. And a gate would be set up this way. You have plus V, come here, have a switch, come here, you have a switch. So you have an A switch, you have a B switch. They will make contact over this side. And then over here, I will have my LED to ground. And so the truth table for this guy A, B, and Y. I will construct my binary sequence the same way. This is going to be a 0, 1, 2, 3. How do I write zeros in binary? 0, 0. How do I write a 1 in binary? 0, 1.
1.
How do I write a 2 in binary?
1, 0.
1, 0.
1, 0. How do I write a 3 in binary? A 1 and a 1. So this sequencing is always ascending in binary. Next, what's going to happen on the output? If both of these are open, do I have any electricity lighting up my LED?
No.
None. Zip. If I flip switch B, if B closes, but A is open, will I have electricity going to my LED?
Yes.
Yes, so I will have a 1 here. Suppose I leave A open, suppose I close A and leave B open. If B is open, no electricity goes through B, but if A is closed, will electricity light up the LED?
Yes.
Yes. How about if both are closed?
Yes.
It will still be a yes. So the truth table for the OR gate is presented here. The symbol for the OR gate is presented here. And yes, there's actually contact here and contact here, like so. So anyway, with that, our time is up for this particular meeting. You have your tasks to do with respect to getting the rest of the software up and running. We hope to see some suggestive comments from Gerardo by tomorrow. That might help some of you along, but 2 people have been able to get their board successfully running with Windows 10 and 1 person with Windows 7. So you all should be continuing that. Those of you who have successfully completed Lab 1 and will have uploaded the video demonstrating your LEDs and switches, then go ahead and proceed into Lab 2. And I will have some worksheets for all of you concerning logic gates, at least the A and the and then also the numbering system that we had discussed earlier. Any questions until we communicate again once another before next week? Yes.
So, we talked earlier about Xilinx, but we didn't really talk about Active-HDL and the error message the rest of us were getting on step 22.
Yes, I did. I addressed that. Step 22 is an impediment for you to be able to do the synthesis, and the synthesis will not work unless you have your
license file installed.
Your ESYS pack activated. So you have to have it downloaded, installed, and then activated, because if it isn't activated, the synthesis step will not work. So you're going to have to reread the steps again in synthesis for unpacking it. And for unpacking it, there were 2 solutions. One solution was to use the ISE pack for Windows 7, and the other one, if you have virtualization, then continue with that pack. So both packs work and will allow you to finish. So yes, we did address that, but I don't mind reiterating, okay?
One more question, sir.
Quickly, because I have another class at 7:30.
Sure thing, sure thing. Are you assigning additional homework this week, or are we going to try to catch up?
Yes. Yes, I am. Yeah, you will see questions. You will see questions on the binary numbering systems, as I mentioned a moment earlier, and you will also see some questions pertaining to these gates that I have just discussed. So yes, you will see some worksheets. So the answer to your question is yes.
Okay.
And any other questions that come up, by all means, just go ahead and buzz me through Canvas, and I'll be happy to answer your question. So right now, before we part company, I need to take a picture of our class. So get your cameras on, because I need to see your smiling faces. Front camera. Camera, Carlos, Chan, Jeremy, Gerardo, let's go.
I don't got my webcam installed.
Carlos, Gerardo.
I don't have a webcam.
I don't have webcam available at this moment right now.
Okay, I have everybody smile.
Oh, wait, 1 second.
Done. All right, fantastic. I will see you in Canvas on your question sets. We're signing off now. Thank you very much for your kind attention, and keep up the good work.
Okay, thank you, Mr. Cole.
Thank you, guys. Bye-bye now.